Hey everyone, hope you're all doing very well and welcome back to another one here on the channel. In today's video, I got a good one here for you because today what we're doing is we're comparing how we can charge packs in parallel. If we take 4 batteries, we put them in parallel using a board, and then we charge using a 1-channel charger, how that compares to charging a battery pack if we have a 4-channel charger and we can independently charge batteries. To get things started here, I want to show you GT Power sent me this charger. This thing's pretty incredible. It's a 4-channel charger. I've never owned a 4-channel charger before, and this has the capability of charging 4 different batteries at 100 watts apiece, giving you a total of what it says here in the corner, 400 watts. Now this thing I believe does up to 4S LiPo, and that's going to be plenty enough for the guys who have those small 2S packs, 3S packs, or 4S packs, somewhere around the 2200 milliamp hour. If you have batteries that are around that size, this is going to be your ticket because it has the capability of charging those types of packs at a good clip. Let's kick the video off by just jumping into exactly what's inside this box. It's the X4 Mini. So let's take a look at what this thing packs inside. So I'm going to open up the case and show you exactly what we have inside here. Right away we got our charger sitting right on top, so we can move this off to the side and get that out. This is what it looks like. It looks like we got all of the charging ports on the side. Here's 2 channels. I'm expecting 2 channels here as well. And then we have also DC input, and we got a PC USB port as well there, and we got AC on the one side here. So that's what that looks like. We're gonna get this thing fired up here very shortly, but first what I'm gonna do is I'm gonna go and take a look at what else comes inside this box, and not really expecting much. Okay, so we got our AC power cable, and that's it. So we're gonna power this up using a 19-volt power source so we can get a little bit more than 100 watts of charging power for this unit. All right guys, now what we're gonna do is we're gonna take our single channel charger and we're gonna charge at a rate of 1.5 C. Let's go ahead and do that. All right, we're gonna get into charging all 4 of these packs using our charger, single channel using a multi-board. So these multi-board, all of the parallel circuits here for the balance taps are paralleled right into our wire here. Now I had to actually reverse this wire. I can make a video on this. This was kind of scary for me to realize that everything's kind of reversed, and I had to go and take this adapter and reverse it myself, which may be the reason why on this charger you actually have the positive in the wrong location. It might be that, but either way, batteries are all the same and never have the positive on the right-hand side of your balance connector, which would be here. So now that I figured that out, I can redo the video with this properly done. We're going to start off by taking a look at all of the voltages. So taking a look at this 2S, we got cell voltages of 3.777, 3.777 for cell 2. So both of those are identically matched. We go into the second battery pack and we got 382 and 3818. We go and take a look at the third pack, just making sure all of the batteries that we're going to be plugging in are relatively close in voltage. I want to take a look at cell 1, 3774, and cell 2, 3777. I'm going to go back and take a look at that first one that we did. This first one here, 3777 and 3777. Okay, so it is 3777. It's an interesting number there. In our final pack here, this is number 4, we got cell 1 at 3818 and cell 2 at 3818. So very much in balance for every single pack that we're looking at here today. And now what I'm going to do is place them onto our balance and power board, and what I'm going to do is start up our charge. So this is a 13.2 amp charge, because what I've done is I've taken 2.2, I've multiplied that by 4, and I've multiplied it by 1.5 C. So we're going to see if my battery is charging here, and it is, so we're good to go. So as that's charging, we're going to go and take a look at a couple items here. The purpose here is not to make a parallel charging video and the most correct way to do this, but to compare if we're charging at 1.5 C here on our 4-channel charger, I want to do the exact same here on a single channel charger as well. So we're going to come back and talk about the reading that we get at the 1 minute mark. All right, we're just here at the 1 minute mark and we get a total milliohm IR reading of 1.9. So one of the major things about this is that your single reading that you get on this is not going to be accurate. For example, we're seeing 0.9 milliohms for cell 1 and roughly the same for cell 2 there at 0.9 milliohm. The problem with this reading is that we don't actually have just 2 cells. We actually have 8 cells in total here, but 4 of them are actually being doubled up, quadrupled up on a single cell. So that actually means that multiple cells are placed in parallel. This makes sense because we have a parallel board here that gets 4 battery packs into one. So you can never really rely on this information because it's only going to tell you the total that you're seeing and not individual packs. If you're always parallel charging your battery packs, you can never look at this type of information to really look at the performance of an individual battery pack. We just started our ramp down from 13.2 amps. We're sitting at 11.7 amps, and I thought I would share this information with you. So what's actually happening right now is the charger is seeing 8.45 volts. However, if we actually go into the cell voltage is just over 4.10 volts at 4.118, and both of those cells are actually at the exact same voltage. Now the problem with this is that we're going to have a long ramp down time as this current is no longer at 13 amps and we're still low on voltage. But what happens is our charger is going to limit the current because it sees 8.45 volts. For safety, it doesn't want to overcharge the cells, which is kind of funny because the cells we can see are definitely under that 4.2, but this is showing as 4.225 volts per cell if we go off of this. So what's actually causing this? Well, what's causing this is actually the circuit from our charger all the way into the board. There's lots of wires and traces and things that are conducting the power to all 4 of these battery packs here that's adding to the overall resistance to our battery pack. If we didn't actually have our voltage taps plugged in right now, we would probably see this at 20 milliohms. Actually, I did that, and that's why I know that. It was seeing 20 milliohms, 10 milliohms per cell, or 20 in total with 4 battery packs put together. And we know that's not the case. If we actually go into the milliohm internal resistances here, they're a little bit lower because now we've put some power into those packs. They've warmed up slightly internally in the chemistry there and are showing better values of resistance. So overall, that's what's happening, and it's another disadvantage because we're losing out on the opportunity to hold the maximum current all the way until those packs or cells hit 4.20 volts. We're now at 1.88 amps in terms of our charge rate. We're slowly getting down to that 1.3 amp cutoff. You can see that it's been 20 minutes now. This doesn't represent the full duration of how long we've been charging. Unfortunately, I had a maximum capacity that was reached and then the charger stopped the charge there. So I didn't get the full reading that we should have on here, but we can go back and take a look at what that value was and know how much capacity on top of that we ended up adding back into the pack. I think it was somewhere around 2,300, so we're looking at about 5,000 plus going back into this pack across 4 batteries. We can now see we're jumping down to 1.75. I am expecting this charge to stop once we get to the 1.3 amp mark, and then what I want to do is compare the ramp down cycle of this battery charge cycle versus the other one. It took about 10 to 15 minutes to get up to that capacity limit, and then I did start it again. So overall, we're probably looking at 35 minutes of charge time right now at a rate of 1.5 C, and it just went down to 0.83, 0.5. I think this is where it's going to terminate the charge. We're going to see here, and there it is. So now we got the full charge of the battery here. All 4 of them, 8.422 is what it says all the cells are at. And we're going to go through and test all the cells. We should see somewhere around 4.20 volts. Now I'm going to fire them into our meter here just to see what this is saying. So the first pack comes in at 8.40, 4.198 volts, 4.20 volts, so pretty good. That's fairly balanced. I would be okay with that. We go into our second pack. We got our 4.197, 4.20. So interesting there, 0.005 volts out or so. We go into our third pack here, and we're getting 8.40 total, 4.198 versus 4.203. And our last pack, we'll check what this looks like here. We're getting 4.197 and 4.201. So overall, our balance is pretty good. Now that we have charged using our single channel charger, let's go and take our 4-channel charger and charge up our batteries from storage voltage. All right, guys, just before we get started, I'm going to use this balance capacity meter here in order to determine the voltages of the pack. So let's go through this as quickly as we can and just get the voltages of where we're all starting at for this. First battery that we're plugging in here, we're at 3815 and 3817. Take a look at the second battery. We're at 3806 and 3807. Looking at the third battery here. Third battery checks in at 3809, 3810. And the last battery pack is checking in here at 3809 and 3810. So now the next thing that I'm going to do is I'm going to hook these balance taps up, and then we'll jump right into charging these packs. Okay, we are all hooked up, and now we're going to go through our battery selection mode. Now, I'm so glad that I ended up redoing this video, because now I checked the camera, you can definitely see this. What I did to do this is change my lighting. I'm now turning the studio lighting off, and I'm just using my ambient room lighting, which seems to work for some strange reason. Either way, let's go through with this. I have the battery type selected as LiPo, so I'm good to go here. We're going to fast charge it at 3.3 amps. Now, this is already coming up in the proper configuration because I set that in the previous attempt for this video, which was on the weekend. So now I'm going to go through and I'm able to start the charge for here. All I need to do is hit it, turn it on, confirm that it's okay, and it's off. So now I can get into the next one, and I'm doing the same thing. Battery type LiPo, all of this is correct. So I'm going to go to the next mode and get it to charge here. Confirm, yes, and then we're going to go to the next channel. That's ramping up already, and we're going to go through, and we hold it down, we fire that, and confirm. And now we got our third battery charging, and we're going to go to now the last channel, and it's represented by this dot. I talked more about this in the last video, so this is now going to be fired as well, just by holding this down and then confirming, and now we're charging that 2S. So now we got all of the packs charging. We can go back to the first one here. This is already ramped up to 3.3 amps, 7.70 volts. Now you see the individual cell voltage for each one of these packs. We can go through the screens just to see exactly what we get from this charger, the X4 Mini, and we get the individual voltages on the first screen, and then we have it's at 54%. The cell there is 3.85 on average. And then if we go to the minus sign, we get a couple different properties here. We get the capacity cutoff. This is set as a default at 10,000. If we go further in the screen, there's a safety timer that is turned on for 300 minutes. We won't be anywhere close to that. We have a temperature cutoff at 65 degrees Celsius. This must not be the temperature of the battery packs because it has no clue what temperature these are at. Must be the internal unit. And then if we go to the next item here, this is the internal temperature. Right now it's at 29 degrees Celsius. I did notice in the previous video that the fan does kick on around 38, 39 degrees Celsius. And it does sound a little bit funny as the controller's trying to spin up the fan, but it's pretty quiet. So it's a lot quieter actually than when we were charging parallel on my single channel charger. This thing is definitely quiet. It makes a weird, strange noise, but it's still quieter. In the next menu here, the power that's coming in is at 19.3 volts. And the last thing here is showing the channel power. So each channel is about 25.2 watts, totaling 100 watts. This is not using the full potential of this charger, which is at 400 watts total. So you can imagine if you add more cells to this, you could still charge, a 4S pack at a good clip in order to charge up batteries of this size fairly quickly. So it's really good for those 2S, 3S, 4S airplanes or radio controlled cars, boats, whatever, that have these small batteries. Drones as well, when you want to get a few of them pumped up really quick on separate channels. And you don't need to worry about whether this is at a capacity that that is much higher than the others. All of that is going to be controlled because we have independent channels. And then we're going to see the overall amount of time that elapsed when this ends up getting to that fully charged state. All right, we're just creeping past that 4.0 volt mark, which is where the other one ended up stopping because of that capacity limit. So that gives us about 13 minutes or so of time in order to get to that point. So it'll be interesting to see exactly how much more time it takes for all 4 of these cells to fully charge. All right, it sounds like we just got one of the first batteries done. So let's see which one that is. And that is channel 2 here. It's finished. It looks like it took a total of 22 minutes to get 1074 into that pack. And its charge voltage there says it's 8.4 volts. So we're going to wait until the other ones are done, and then we're going to pull it off and see exactly what the final voltages are for these units. And it looks like we got our second battery here done. So there's the first one that was done. And there's the second one now done. And we're getting our third battery pack done. So this one took 24 minutes. We'll find out where the other one is. And that is right here. This one here took 24 minutes, 34 seconds to get 1200 into this one versus 1173 into this guy, finishing at 20 seconds quicker there about. So now we got only the single one here left. We're going to check the voltage of each of the cells. They say that they're 4.20 volts. I am expecting this to be done very, very soon here once that 0.6 ramps down under that 0.3 amp mark. And now we have our last battery pack that took 26 minutes to get 1250 milliamp hour into that final pack. One of the biggest things about this charge sequence is that these packs, when they were at 4.04 to 4.1 volts per cell, this thing was still pumping at 3.3 amps, where when we charged in parallel on a single channel, that was not the case. It would be ramping down a lot sooner and dragging out that process well beyond this time. So this time it took just to go from 4 point something volts all the way up to 4.20, where we did the entire charge from 3.80 volts all the way until we got 4.200. So now what I'm going to do is I'm going to pop off all of the balance ports here, and we're going to start measuring the voltage to the final resting voltage. And because these take a little bit less time to charge, I'm expecting that the cell voltages are going to be a little bit different. So we got the first one here. This has been the one that has been waiting the most, 4.177 and 4.190. On battery pack number 2, we got 4.195 and 4.196. On battery pack number 3 here, we have 4.198 and 4.195, and the final battery pack that we have here, cell 1 is 4.177 and 4.195. If I go back there, 4.177 is the cell voltage there for that one. So as I mentioned, because these are being done so quickly, and as soon as they hit that maximum voltage, the charger cuts it off. It allows the batteries to sag a tiny bit in voltage and come down to a slightly lower amount. Go back to the very first one. This had the most significant difference. 4.177, 4.190 are the two packs. So you can see we lost about 3% off of that. And if we were to charge at a slower rate, matching the time that it took for the other ones to charge, when we parallel charge, it took 4 batteries, 35 minutes. If we added another 10 minutes to this, we could definitely get it up to 3%, but it's hardly worth it. I will take this over anything else. I would take 26 minutes for 4 battery packs as opposed to 35 minutes for 4 using a single channel charger. Now let's sum up what we have seen. In conclusion to this video here, I want to point out a few specific items. And one of them is the freedom and flexibility that you get from a 4-channel charger. The 4-channel charger allows you to charge at different capacities. It allows you to even charge different voltage battery packs. You don't need to have all the same batteries. You can have 2S's, 3S's, 4S's. It doesn't matter. And you can charge all of them all at the same time using that 4-channel charger. And another thing is you don't need to have all of the packs. If you are parallel charging a bunch of 2S like we did here in the video, what you can do is have them at different capacities. But if you're parallel charging, you don't want that. You want the voltages to be roughly the same when you're looking at the cell voltages alone, like we did in this video. That's going to make it easier to parallel charge. Otherwise, we're going to have batteries that are going to discharge and charge amongst themselves. Another point to point out here is the speed that we are able to get these things charged up at. We're talking well over 30 minutes using a parallel board, but we got all 4 batteries done within that 30-minute period, which is significant if you're talking about timing. Based on what we see, which way should we go? Should we get a parallel board or should we get a 4-channel charger? And it really comes down to what you already have. If you're looking for a charger and you don't have something that suits your needs, you're going to want to go the 4-channel way, that direction, if you have multiple battery packs that you want to charge, especially more than 2 or 3. If you have that 4 or 5 or 6, you want to get one of these multi-channel chargers. Now, if you already have a charger and you're really happy with the capabilities of that charger and everything, you're probably better off just spending, $20 and purchasing one of these parallel boards, and this way you can get everything charged up. You're going to be faced with the inconveniences of that parallel setup, but at the same rate, you're going to be able to do it as long as you're safe with having the correct amount of voltage per cell when you end up charging in parallel. If you want the full freedom and flexibility, then you have to go to a multi-channel charger, and this is the only way you're going to get that freedom and flexibility in terms of charging all different voltages, or if you have them at all different capacities, you don't need to worry about any of that. You can go ahead and charge the batteries. I'm going to leave a link in the description if you want to pick up one of these chargers for yourself. I'm also going to leave a link in the description below if you are looking for more information on the details of parallel charging. We cover all of that in another video and go into a little bit deeper of what to look out for, especially when you're talking about the voltage differences that we kind of talked about in this video. Well, guys, hope you enjoyed it. As always, like the video if you do. Don't forget to hit that sub button so that I can see you guys in the next one. Thanks a lot for watching. See you in the next one.